Okay, so in the last chapter, we have discussed several, if you want, strategies in order to reduce the risk related to projects. We know especially that renewable energy projects have a certain disadvantage that they have a very high investment at the beginning. That's why we try to make them more attractive, to come up with different de-risking strategies, okay, in order to, let's say, make them more economically viable and more attractive for people to invest in. So in general, in this chapter, we can ask you to construct, if you want, the waterfall diagram that will show you how you are reducing the risks, okay? So sometimes I can ask you to draw how, if you want, we have the variation from before putting the de-risking strategies and after putting them. So we can show then how we can, when we implement the different strategies, we can reduce a lot the risk related to the project. Okay, so for example, we can, in such cases, to be able to construct these diagrams, we should give you like if you want, some statistics that will allow you to assess the importance of each de-risking category. Okay, so for example, I can tell you I have a certain project and I am implementing several de-risking strategies. We have seen in the course material that we have a lot of types. For example, one possibility is to implement policy de-risking. So let us consider, for example, that policy de-risking is the first category. So I will consider that this is category 1. I have, and here, for example, we can ask you in the exam, give some examples of policy de-risking method. So you can say, for example, I can first, let's say, update the grid code for renewable energy. I can build some skills and expertise in order to manage such a project. I can have a better infrastructure, work on the infrastructure of the grid in order on the long term to have a better project, etc. Okay, so these are some examples of policy de-risking. You can talk also about financial de-risking. So here we have also a lot of possible strategies in order to make the risk lower and lower. We already discussed several ones in class. So for example, we can, the government, let's say, can impose low interest on loans related to projects using renewable energy. We can motivate people by telling them that you can take a high amount of money if you invest in such type of project, while if you want to use, for example, a power plant using diesel, we cannot give you any, let's say, loans to do this. Plus, we can provide some guarantees for commercial loans, which will engage the local financial sector. And we can, at the end, the purpose is first to give motivation, but at the end, after research and development and making, this will make the cost of renewable energy project lower. So for example, if we consider, let's say, solar energy, if you remember, we have seen the variation of the cost, how it was decreased significantly with time. So it was very expensive at the beginning, but with improvements, we were able, and research development, we were able to reduce the initial cost and investment of these techniques, which made them already competitive with the market. So even if we don't put incentives, if we don't give a lot of help to get loans with low interest, even without this, people will go and invest in it because the cost is affordable, and these methods are beginning competitive with even the conventional fossil fuels technique. So in each strategy, you can see that we can do, if you want, several de-risking first on short term, medium term, and then long term. So because if we talk about the same example, at the beginning, the cost was high. So it was not possible that people invest without any motivation. So we started by offering loans with low interest. But after this, with time, since the sector was developed, so it was already attractive without having to motivate people to do this. So we try also that with time, we should always work in parallel. Yani we put some strategies on the short term and we work that on long term, we can reach a state where the renewable energy project is really financially independent and is attractive for people. Other possible strategies, let's say we can talk about direct financial incentives. And you have, for the financial de-risking, you have several parts. You can talk about, as we said, the financial de-risking, but also you can talk about direct incentives related, let's say, to taxes. So we can talk about then direct incentives. So we can impose taxes on projects that are not using renewable energy to make renewable energy more competitive. So this can be categorized as, let's say, direct incentives, and it is in another category. And you have also possibly social, environmental, and you can have a lot of categories that are important. So depending on the project, we decide which categories are the most important one. So here we can talk about, let's say, as we said, about taxes. So when we impose taxes on a project, let's say, harming the environment, then we can this will be in favor of renewable energy, which is free and which will not harm the environment. So so after this, by doing these strategies, we can go from bad strategies that have a bad effect on the environment to go to clean strategies. Because when you impose high taxes, let's say on CO2 emissions, then people should be should take care of producing a lot of CO2, and then can start to think about replacing these conventional techniques with other ones. So for example, let us consider we have 3 categories. You can have more, of course. You can have 4, 5, 6. So, and divided into several categories: environmental, social, economical, etc. So I will give you, let's say, different categories, and I can maybe tell you to suggest what can be other categories that we can consider. Okay. So you just, from reading the slides, you can have an idea about the different measures that will allow you to de-risk your project. Okay. So once we specify the different categories, we should do like a small questionnaire in order to determine their importance. So if you want, it's a little bit similar to how we were putting weights, if you remember, in the decision matrix, but you have a certain specific technique for this, okay? But the idea is always the same. Yani we try to ask, if you want, several people, we ask them specific questions. In case of decision matrix, to put weight, we did the pairwise comparison, if you remember, to decide on the weight of each criterion. Here we have, in general, when it comes to risking or de-risking, it's about mainly a questionnaire of 2 questions. So, and this will test mainly the probability of an event to happen. And for example, let's say, for example, if you talk about coronavirus, okay, the impact of coronavirus is really very bad. So it will increase a lot the risk. And if we were aware that corona will take place, we know that it will lead to a very high risk. But the probability that this event occur is really small. And when you talk about, let's say, a virus spread, what is the probability of this event to happen? It's a very small probability. And in general, you have some viruses, but they will not spread over the whole world. They will not cause, if you want, a damage on the universe, if you want, level, unless they will spread in the whole world, and like corona. So the probability of such events is really small. It's rare. And each, let's say, maybe 100 to 100 years, will not see this. So so an important factor will be the probability of a certain risk category to happen. And after we assess the probability, we should know also the impact. So if a certain event a high probability to happen, and it will have a high impact on the project, then of course it will, the score which will be given to it will be high. Okay, that's why in general, in the questionnaire, we divide it into two parts. So the first, so question one will tackle the probability. And we can ask in the interview, we can say, how would you rate the probability that this event will take place? And we'll tell them to put a grade, okay? So as usual, even the scale, if you want, the scale can vary. And in the exam, I will specify for you the scale I am using, okay? Let's say here I decided to use, for example, a scale from 1 to 4. Okay, you can use a scale from 1 to 5, from 1 to 10. So this is not fixed. So for each, if you want statistics that you are doing, you should first specify your scale. And you already know that more you divide your scale, the better it is. Okay, because you can have a more detailed grading if you want. So I can tell them, if it is, let's say, unlikely to occur, put a low grade of 1. If it is very likely to occur, put a grade of 4. And let's say if it's a medium probability, you can put in between. So you can have scores, let's say 1, 2, 3, 4. Okay, 2 and 3, if you want. 3 is closer, it's likely but not extremely, and 2 is not extremely unlikely, but it's closer to unlikely. So you can put a grade from, let's say, 1 to 4. Okay, and after you ask for to put a score on the probability, you will ask also to put a score on the impact. So okay, maybe like corona or the spread of a virus, it has a very high probability, a very small probability, but it will have a very high impact. Okay, you have some factors that will have, of course, when I talk about corona, it's not a de-risking, it's a risking profile. Okay, so if you remember, even in this chapter, you can study risks and de-risking. So whenever you have a problem, the problem can be to consider what are the risks and how each category will increase the risk of the project, or the question will be on de-risking measures. Okay, so if we give you in the exam a problem on different risk categories, and you want to draw the diagram, you will have your diagram starting from the, if you want, we also compare to a best possible profile. And for example, you have a developed country for which the risk is very small, and you want to compare a country under development with it. So you can say, if I have the first risk category, let's say I have 4 risk categories. The first one will lead to a certain increase in risk compared to the basic case. So I can put the percentage. We'll do together how we do the calculation. I construct how much I will increase the risk. I have another risk category, a third one, a fourth one, etc. So for example, coronavirus can be one of the risking categories that will increase the risk. Okay, and you can have economical factor, you can have environmental factors, etc. So after if you want, accumulating the different risking factors, you will end up with your total new risk, which is the basic risk plus the risk due to the different risk categories. Okay, so it will be just here to be on scale. Okay, so if you want, this height will represent the percentage of the value of increase due to each risk categories. So you do this plus this, you reach this level. then you add this to reach this level, etc. Okay, you don't have to do it on scale 100%, but it should be just let's say if you have here 6 and here 2, try to have some proportionality, and it should not be like this, for example. Okay, so to be just reasonable in the diagram. Okay, so here since we are talking here about de-risking strategies, so instead of having increase as we implement strategies, we'll have decrease, and it will start by a relatively, let's say, a high risk, and this will be reduced by implementing the de-risking strategies. This is the only difference between constructing a diagram showing the effect of risk categories and another one showing de-risking categories. So here it will be increasing, while for de-risking strategies, it will reduce the risk with implementation of the de-risking strategies. Okay? So also for the impact, we have to ask also questions. So to consider if we have a low impact, high impact, or intermediate impact. So also here we can have a scale. Let's say sometimes you can have the same scale for both, or it can be different. So it depends. Okay, so let us say, but in general, the scales used for both are the same. Okay, so here also you can say I will use the same scale: 0, very low, let's say, impact, for very high impact, and in between I have, let's say, 2 and 3. Okay, now, so after we specify these scales and what are the questions we'll ask you, then we will give you a table. Okay, we'll give you a table showing you what were the average scores. Of course, when you do these statistics, you will ask a high number of people on their opinion. Okay, so and you get average scores for each of the questions, and then you will ask this question for each category. You say, for example, for de-risking category 1, what is the probability that it will happen, and what is its impact? You ask the same questions for categories 2 and 3. Then you will end up with a table that will summarize your scores. Okay, and now once you have these scores, we'll see how to get the total score, and if you want, then you can assess the importance, which is equivalent to the weight, if you want, of each of the de-risking measures. Okay, so for example, let us say we provide the following table.
Professor,
Yes?
will we put the scores, or the scores will be
No,
given?
of course. I will give you the scores, of course. So this table will be provided for you. Okay?
Okay.
And I will tell you, I can tell you, for example, you have
And
these risk categories. Okay? These are the 2 questions that I am asking, and this table will summarize for you the scores.
Okay, yeah. We will have everything like related to and we will do everything, and the calculation.
Yes, you will do the calculation,
score.
exactly. I just give you the input, and you should know how to calculate the score, how to determine the percentage, if you want, of each category. And each category will lead to a reduction in the risk. Okay, so you are responsible to know what is the amount of reduction of risk due to each de-risking measure.
Okay, yeah.
Okay, so we have de-risking category. So de-risking category number. Let's say here we are considering, let's say, as we said, 3 categories. So 1, 2, and 3. Okay, and as we said, we have 2 scores, one for the probability. So we have here the score for probability, and here you have the score for impact. Okay, so for example, let us say we have here a 3 and 4, 2 and 3, and 1 and 2, for example. Okay, now look here, when you want to compute the total score, one method, so the method that we learned in the course material is to multiply the numbers. Okay, this is not the only method. Maybe you can tell me why I don't add them. It might be a strategy, okay, because also adding them will allow you to consider the effect of each of them. So if I don't specify for you a new calculation technique, please use the ones developed in the course material. So I multiply the numbers. If I tell you calculate the total score, let's say based on summation of scores, or I can give you any formula, okay? I can tell you, for example, compute the total score as equal, let's say, to a certain multiple of the score of probability plus another multiple of the score of impact. It might be, okay? So it depends, if you want, on the statistics, and when they study numbers, they can decide maybe which method is the best one to find the total score. Here in the method we use in the course material, we just multiply the numbers. Okay, so unless I specify for you another empirical relation to calculate the total score, just do the multiplication. Okay, so I just do 3 times 4 equals to 12. 2 times 3 equals to 6. And 1 times 2 equals to 2. And once I do this, okay, I can find the total score across all de-risking strategies. Okay, so I just have to sum these 3, 12, 6, and 2. So I have 20 as a total score. Okay, so I can consider then it's clear that the de-risking category number 1 is the most important, because it has the highest score. Okay, so it will contribute to the largest decrease in risk. Okay, so it's, if I want to calculate it as a percentage of reduction, it is 12 over 20. Which is 0.6. Okay, and here I have 6 over 20, 0.3. And finally, 2 over 20, 0.1. Okay, so this is the percentage of reduction of the risk due to each of my risk categories. So I can say that de-risking category number 1 will reduce my risk by 60%. Category number 2 will reduce my risk by 30%. And the final one will reduce my risk by 10%. Okay, now once I do this, they should give me, if you want, what is the total risk before implementing the de-risking strategies, and what is the final risk, okay, after I implement all my strategies, to be able to draw my waterfall diagram. Okay, yani for example, I can tell you that before de-risking strategies, okay, the risk of implementation of the project, let's say, was 20%. Okay, and after de-risking, after implementation of de-risking strategies, the risk will become 10%. Okay, so I repeat, this will be also given for you. So what will be given for you is the score, the risk before implementing the strategies and the risk after implementing them. Okay. And also I will give you these numbers to be able to compute the total score. Okay. And then once you have this, it's really simple how to draw the waterfall diagram. Okay. So all you have to say is to consider that if I want to draw a figure, first I have a reduction of 10%. So I need to compute the difference, the total difference between the two. I do the number before de-risking minus the number after de-risking. So the difference is 20 minus 10 is equal to 10%. The whole idea is to see how this 10% is divided. Okay, so how I am, each category is reducing a certain part of this 10%. And since I already studied the effect of each category, it's very simple. All I have to do now is to consider for each category its score, okay, its relative score as percentage, times the difference created in my risk. So my risk was reduced in total by 10%. And since the de-risking category number 1 is contributing to 60% of this decrease, so I can say that the reduction due to de-risking strategy 1 is 60% times 10%, and it's 0.6 times 10 equal to 6%. Okay. I do the same for the other. So the second category will reduce my risk by 3%. And the final category will reduce my risk just by 1%. Okay. And now I am ready to draw my diagram. You can, of course, summarize this in a table. So let me tell you how you can present it in a good way. You can construct a new table. Always summarize your result in tables. This will make them, if you want, clearer and well organized. So now you add a table. So the first column will be the de-risking category. As we said, we have 3 categories, 1, 2, and 3. Okay, now we need to determine, okay, but what is the amount of reduction due to each category. So first, this is why we need to put already the de-risking score. And we already computed the score of de-risking, okay, for each part. So we have seen that for de-risking score, we have seen that category 1 will reduce the score by 60%. So we put here 0.6. While category 2 will reduce the risk by 30%, so 0.3. And finally, category 3 will reduce it by 10%, so 0.1. And now this should be multiplied. So we should do times, okay, times the total difference, okay, so the difference in score between post de-risking and pre-de-risking. Here it's pre minus post. Yeah, we do the largest, which is at the beginning, minus the one at the end, because the risk is reduced. So the difference is 10%. Okay, so we multiply each score by 10%. And then we'll be able to find the amount of reduction in risk due to each de-risking strategy. Okay, so reduction in risk So as we said, for the first one, it's 6%. For the second one it's 3%. And for the last one, it's 1%. Okay, and now all I have to do is to present this in a graph, which is very simple. Okay, so I have to put what is happening before and after. So pre-de-risking, I can do a diagram, pre and post. So before implementing the de-risking strategies. And finally, I need to reach post de-risking. So first, I know if you want, I just have to, I don't have to do it with a scale 100% true, but it should be, as we said, reasonable. It was 20%, okay? So I can consider, for example, this is 20%. So I should, since 10% is the half, so nearly it's on this level. So at the end, I should end up here, okay? So here the risk was 20%, and I was able to reduce it to 10%. Okay, so now all I have to do is to put the categories. So this is category 1, 2, 3. So each one will reduce by a certain amount my risk. And according to our calculation, the highest reduction is from category 1. So it's 60%, more than half if you want of this part. Okay, so it's nearly like this. And you can put, if you want, after this de-risking, since I reduced by 6%, I will reach 14% here as a level. Okay, then for category 2 will reduce 3%, so I will reach 11%. So this is 11 at this level. Okay, and finally the last category will allow me to reach the 10% final risk after implementing the 3 de-risking strategies. Okay, so as simple as that. It's a really simple technique that will allow me, it will help me if you want to determine the most important de-risking strategies. Sometimes maybe after seeing this diagram, I can say, let me concentrate on category 1 because it will help me to reduce with a high percentage my risk. Okay, I can think maybe about implementing new strategies also. What can be other strategies that can have significant reduction in my total risk. Okay, any question on this? Okay, so as I told you guys, for the final for chapter 7, you need to consider the whole material. You need to know how to calculate, as we have seen previously, NPV, CER, payback period. I can ask for the life cycle cost of electricity, because once you know to calculate incomes and costs, you can calculate several parameters. Okay, so it's just a formula. I provide the formula for you, and just you have to apply it. And if you have any question, you can send me your questions anytime. Okay, thank you.
Thank you, doctor.
Bye bye.
Thank you.
Welcome. Bye.